Hello, class. Today we're going to be reading a book, Where the Wild Things Are, Story and Pictures by Mari Sendak. And we will also be performing a science experiment called Float Your Boat, where we would create boats using pool noodle pieces and toothpicks, and we will be testing its buoyancy. Where the Wild Things Are, Story and Pictures by Mari Sendak. The night Max wore his wolf suit and made mischief of one kind. And another. His mother called him Wild Thing, and Max said, "I'll eat you up." So he was sent to bed without eating anything. That very night in Max's room, a forest grew. And grew. And grew until his ceiling hung with vines and the walls became the world all around. And an ocean tumbled with a private boat for Max, and he sailed off through the night and day. And in and out of weeks, and almost over a year, to where the wild things are. And when he came to the place where the wild things are, they roared their terrible roars and gnashed their terrible teeth, and rolled their terrible eyes and showed their terrible claws. So Max said, "Be still," and tamed them with the magic trick of staring into their yellow eyes without blinking once, and they were frightened and called him the most wild thing of all. And made him king of all wild things. And now, cried Max, let the wild rumpus start. And so they rumpused away. And more. And more. Now stop, Max said, and sent the wild things off to bed without their supper. And Max, the king of all wild things, was lonely and wanted to be where someone loved him best of all. Then all around from far away across the world, he smelled good things to eat. So he gave up being king of where the wild things are. But the wild things cried, "Oh, please don't go. We'll eat you up. We love you so." And Max said, "No." The wild things roared their terrible roars and gnashed their terrible teeth, and rolled their terrible eyes and showed their terrible claws. But Max stepped into his private boat and waved goodbye. And sailed back over a year and in out of weeks and through a day. And into the night of his very own room where he found his supper waiting for him. And it was still hot. So after reading this book, I want you to pause this video and think of what happened in this story and what were some of your predictions, and were those predictions correct? And also, did you see any elements of what we're going to be doing today as far as creating boats and testing its buoyancy? And I want you to resume this video when you are done. So now we will be going over the objective. I want you to read this objective with me together. Today, I will create a sailboat using toothpicks and pool noodle pieces. I will test the strength and balance of their boats by blowing wind through plastic straws to move their boats. For the vocabulary, we will be going over buoyancy, capsize, mast, and hull. Buoyancy is the power to float or rise in a liquid. A capsize is to turn bottom up or even turn. Mast is an upright post on a ship that carries a sail. And hull is the main body of a ship or boat. So as we can see, capsize, mast, and hull are all parts of what is used to create a boat to have buoyancy, which is the power to float or rise in a liquid. So to get a better understanding of buoyancy, we are gonna be watching this video called Sink or Float.
Some sticks into a pond, or maybe you like to bring a bunch of toys into the tub. Either way, you've probably found that not all objects act the same when they're in the water. Some things sink right to the bottom, while other things float on the top. Why does that happen? Well, I brought some friends to see if we can figure that out.
Hi, everyone. My name's Webb,
And hi, I'm his sister Bill. Since we live in a pond, we see a lot of things sink.
and a lot of things float.
I bet. You know, you can actually learn a lot about something by seeing what it does in the water. So I'd say this calls for an experiment. First, we'll need a pretty big container of water. We'll fill it about 3/4 full and set it up where it's okay if some splashes out. Now we need some stuff to put in the water.
All kinds of different stuff.
We're going to look for a couple things around the fort that are okay to get wet. If you want to try this experiment at home, make sure you ask before you put anything from your house into the water. Let's see what we found. All right, Squeaks found a penny. I found a stick. And Bill and Webb, they found 2 different spoons, a metal one and a plastic one. Good job, guys. Now, before we get started, let's take a closer look at what we'll be testing. All of these things are made out of different materials, like metal, plastic, and wood. Some of them are pretty small, and some are a little bit bigger. I think we have a pretty good group of objects because they're all pretty different. Now, before we start putting things in the water, let's guess whether each one will sink or float. And let's keep track of our guesses. But how will we... Great idea, Squeaks. We'll use a chart. All right, let's start with the stick. Bill, Webb, what do you think? Will it sink or float?
Quack,
Well, I can tell you guys are pretty excited. Tell us what you're thinking.
Well, in the pond where we live, I've never seen sticks that have sunk, only ones that float.
Well, that's because you haven't seen the ones that have sunk.
Well, that's because they all float, Webb.
Okay, fine. Put me and Bill down for the stick floats.
Okay, here we go. And it floats. Good job, you two.
Yay!
Next, let's try the metal spoon. What do you think? Will it sink or float?
Well, I've never seen a spoon float.
Me neither.
Quack.
Quack, quack, quack. We think it'll sink.
Okay, let's see. It sinks.
Yeah, we're the smartest ducks in the world.
Yeah. Now, what about the plastic spoon? Do you think it will sink or float?
Quack, quack,
Quack.
quack,
Quack, quack.
quack, quack. Well, it's the same shape as the other spoon.
Yeah, and we think it might sink, just like the metal spoon did.
Okay, let's see. It floats.
Oh,
Bummer.
Well, that's okay, guys. That's how we learn, right?
Yeah, I guess. It's just weird. The other spoon sank.
Well, let's record our results and see if we can find out why it sank after we test our next object. Our next object will be the penny. Do you think it will sink or float?
Well, a penny feels a lot like a metal spoon, so I think it'll sink.
All right. And Webb, what do you think?
well, it's so light, but kind of small, and I don't usually see things that small floating. I'll have to agree with my sister this time. It's gonna sink.
It sinks!
Whoa!
Now that we've tested all of our objects, let's look at our chart. Some of the objects floated and some of them sank. Let's see. The metal spoon and the penny sank. The plastic spoon and the stick floated. Is there anything that's the same about the things that floated and the things that sank?
Well, we know that the metal thing sank, and the metal spoon feels kind of heavy.
But so does the stick, and the stick floated while the spoon sank. So maybe it's not all about how much something weighs or its shape.
You're right, and that might help us explain why some things float and some things sink. The answer has to do with something called density. Everything, and I mean everything, is made of tiny particles that we can't see. And how dense an object is depends on how much space is between those particles.
Particles?
Jesse, what the quack is a particle?
Now that's an awesome question. Let's use our imaginations and pretend that particles are marbles. We'll start with a bunch of marbles on a table. If you had the marbles all right next to each other, that's kind of how the particles would look inside an object that's dense, like the metal spoon. But if those marbles were spaced really far apart, that'd be more like what the particles are like in something that's less dense, like the plastic spoon. The metal spoon is more dense than the plastic spoon. It's about the same size and shape, but the
So after looking at that video, we saw some examples of some things that sink and some things that float, which ultimately, the things that did float, like the plastic spoon and the wooden stick, had buoyancy because they were able to float in water. Now, these are just some examples of the boat in Where the Wild Things Are and how Max used this sailboat to travel from the real world to where the wild things are. And we will be creating something similar to this. We will be creating our own sailboat that will also have buoyancy and that we will get to float in water. So now for the directions, I want everybody to gather the materials provided in your science kit. There should be toothpicks, pool noodle pieces, plastic straws, and individual booklets. I also want you to have a pencil ready to record your observations in your individual booklets. Also, with the help of an adult in your home, I want you guys to have a tub of water ready to go, similar to how they had it in the video. Next, I want you to create your boat and test the strength and balance of the boat by blowing wind through the plastic straws to move the boat. So after you have created your sailboat using the pool noodle pieces and the toothpicks, and you get it to float in water, I want you to grab the plastic straws and blow on them to create wind. And I want you to see what happens to your sailboat when you do so. Please pause the video right here, and then you can resume once you are done. Make sure you record any of your observations in your individual booklets. Now that you are done with your science experiment of float your boat, I want you to think about, what did you learn about sailboat designs and buoyancy? So we learned how to create a sailboat and design one to where it is effective enough so that it can float in water. We know that sailboats require a capsize, a mast, and a hole to be able to float. The ability to float in a liquid is called buoyancy. And that is how our sailboats that we created together floated in water. Thank you for this lesson, and I hope you learned a lot about sailboat designs and buoyancy. Have a great day.